Question 1. Find the next term in each of these exponential sequences. Okay, we need to see how we're getting from term to term. So from 12 to 36, they said it's exponential, so it's not linear, it's not quadratic, and it's not cubic. So you don't have a first, second, or third common difference. We need to see if there's a multiplier, right? Because it's exponential. So from 12 to 36, we times by 3. From 36 to 44, we times by 4. So the next term we are going to times by 5. So the next term will be 720. 144 times 5. B, 13, 39, 117, 351. Again, let's see what we're doing from, instead of doing it this way, what times what, we'll just divide term 2 by term 1. So 39 divided by 13 is 3, so 13 times 3 is 39. 117 divided by 39 is 3, so we multiply 39 by 3, and we multiply 117 by 3 as well. So the next term will be 351 times 3, which is 1053. Next sequence 2, 10, 50, 250. To find the multiplier, divide each term by the term before it. So 10 divided by 2 is 5, so we multiply 2 by 5 to get 10, multiply 10 by 5 to get 50, and 50 by 5 to get 250. So the next term will be 25 times 5 is 1255. In this question, we're given the nth term of some sequences. We're required to find T1, the first term, and the fourth term, T4. So the nth term, and write it like this, Tn equals 6 to the n. The first term, T1, will be where n equals 1. So it'll be 6 to the 1, which is 6. The fourth term will be when n equals 4. Term 4 is 6 to the 4, which is 1296. And you're going to do the same thing with the rest of the questions. So I'll do B, and then you can complete the exercise. Tn is 8 times 2 to the n. So T1 will be where n equals 1. 8 times 2 to the 1. 8 times 2 is 16. Term 4 is going to be 8 times 2 to the 4. That's going to be 8 times 16 is 128. And you complete the rest of the exercise in a similar fashion. In this question, we have to determine the nth term and write it in the form Tn equals. So the sequence is 50, 100, 200, 400, 800. Now, we need to check what the multiplier is. So 50 times 2 gives us 100, 100 times 2, 200, 200 times 2, 400, 400 times 2, 800. So we need a general term where the multiplier is 2. So we're going to have 2 to the power of n. Now, when n equals 1, we need to have the first term being 50. So when n equals 1, 2 to the 1 is 2, and then 2 times 25 gives us 50. So Tn will be 25 times 2 to the n. Now let's check that this works for the next two terms. When n equals 2, 25 times 2 squared will be 25 times 4, which is 100, which is the second term. So that checks out. And when n equals 3, we'll have 25 times 2 to the 3, which is 25 times 8, which is 200. That third term also checks out. Just for good measure, let's check the fourth term as well. Term 4, 25 times 2 to the 4, 25 times 16, which is 400. So the fourth term checks out, and then the fifth term will also check out. So the general term is 25, Tn equals 25 times 2 to the n. Okay, B, 3, 6, 12, 24, 48. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. So the general term will be something times 2 to the n. When n equals 1, the first term has to be 3. So when n equals 1, 2 to the 1 is 2. So 2 times x must be 3. So x will be 3 over 2. So the multiplier will be 3 over 2. So the general term is 3 over 2 times 2 to the n. Now let's check that it's the next few terms are 6, 12, and 24. When n equals 2, we'll have 3 over 2 times 2 to the 2. That's 3 over 2 times 4. 12 over 2 equals 6, so that checks out. When n equals 3, we'll have 3 over 2 times 2 to the 3. 3 over 2 times 8, 24 over 2 is 12. That term checks out, and for good measure, let's find this fourth term. 3 over 2 times 2 to the 4. 3 over 2 times 16. 48 over 2 is 24. The fourth term checks out, and therefore the fifth term will also check out. I want you to do the rest of the exercise in a very similar fashion. In fact, I'll do one more with you. 6, 18, 54, 162, etc. So we're multiplying each term by 3. So the general term will be something times 3 to the n. When n equals 1, the first term needs to be 6. So that's something we'll call x, right? So we'll have 3 to the n times x must be 6. Now when n equals 1, we'll have 3 times 6, 3 times x equals 6, x equals 2. So that will be our multiplier. Now we need to just check term 2. So term 2 will be 2 times 3 squared. 2 times 9 is 18, so that checks out. And when n equals 3, term 3 will be 2 times 3 to the 3. 2 times 27 is 54. And we're going to check the last term. There's only one term left. Term 4 will be 2 times 3 to the 4. 2 times 81, which is 162. So all the terms check out. So this is your general term, your nth term. I want you to complete the rest of the exercise in a very similar fashion. You find the multiplier by approaching it like this when n equals 1. And then you're going to check the rest of the sequence. Question 4. Selena has $5,000 in her savings. She expects her savings to increase by 40% each year. Work out the two numbers missing from the table, and then find an expression for the savings after n years. Okay, so now she has 5,000. A year from now, she'll have 7,000. 2 years from now, she'll have 9,800. So we need to find a multiplier for the first 3 terms, right? And then we can apply that multiplier for the next 2 terms. So this is going to be term 1, term 2, and term 3. So 7,000 divided by 5,000, the multiplier is 1.4. Now check that 9,800 divided by 7,000 is 1.4. It is. So the next term, we're going to multiply 9,800 by 1.4, which is 13,720. And for the next term, we multiply by 1.4, is 19,208. We now need to find an expression after for a savings after n years. So 13,720, 19,208. So this has to carry on to n. So the multiplier is going to be 1.4, and that's going to be to the power of n. And then we have something times that. So to get the first term of 5,000, we're going to say 1.4 to the n times x must give us 5,000. When n equals 1, we need to get 5,000. So that's going to be 1.4 to the 1, which is just 1.4. And then x is 5,000 divided by 1.4, which is 25,000 divided by 7. So Tn will be 25,000 divided by 7 times 1.4 to the n. And this, you do not express this fraction as a decimal. It's a fraction, it's an exact number. Now we're going to check that our answers, that we get the second term, third term, fourth term, etc. Okay, so term 2 will be 25,000 divided by 7 times 1.4 squared, and that gives us 7,000. Term 3 will be 25,000 divided by 7 times 1.4 cubed, which is 9,800. And then just for good measure, let's do term 4. It will be 25,000 divided by 7 times 1.4 to the 4 is 13,720. So it just confirms that this is your nth term. For question 5, I'm going to leave this for you to do on your own. You need to determine, it just says find the nth term. This is how the exam question is going to be asked. They're not going to say it's linear or quadratic or cubic or an exponential sequence. They're going to say find the nth term of the sequence. You have to find out what type of a sequence it is. You're first going to check if it's linear. If it's not linear, check if it's quadratic. If it's not quadratic, check if it's cubic. If it's not cubic, then you check if it's an exponential. And we've done all of these sequences, so I'm going to leave question 5 for you to do. And it's very similar to question 7. Question 6 is also going to be for you to do. Question 7 is very similar to question 5. We're going to do question 9. The sequence 6, 16, 30, 48, 70. The nth term is given by Tn equals An plus Bn squared. By looking at the first term, show that A plus B equals 6. Okay, so the first term is when n equals 1. So term 1 will be A times 1 plus B times 1 squared. A times 1 is A, B times 1 squared is B. So T1 is A plus B. That's the first term. Use the second term to find another equation involving A and B. So term 2 will be, when n equals 2, it will be A times 2 plus B times 2 squared. That'll be 2A plus 4B. Solve the equation from parts A and B simultaneously to find the nth term of the sequence. Okay, well, we know that T1 is A plus B, so the first term is 6, and the second term is 16. So the first term, T1, is A plus B, so A plus B equals 6. There's your first equation. Your second term, 2A plus 4B, is 16. You can just divide through by 2 here to simplify it. A plus 2B equals 8. There's our second equation. We've now got simultaneous equations. So we can use substitution or we can use elimination. Let's do elimination because we've got A in both. So writing the first equation under the second, and then we subtract these to eliminate A. A minus A is 0, 2B minus B is B, and 8 minus 6 is 2. So B equals 2. So A plus 2 equals 6, A equals 4. A equals 4, B equals 2.